Or would you ask a point cloud?
So like, I mean, if you think about where we are today, we are talking to point clouds, but we're just not using natural language currently. So like today you can go talk to a point cloud. It's just not in English. It's in being able to say, I want to find all of these features inside of this point cloud. Yeah, you can do that today. So yeah, I think like that will only become easier. Obviously, there are some manual steps, but yeah, that will totally happen. No promises, but it will happen. We're already doing it.
Hi, I'm Michael Dix with the Point Taken podcast by Trimble. This is our second episode with Alex Okscin. He's a product manager for Trimble's reality capture team based in Westminster, Colorado. In this episode, Alex gets into AI and reality capture, how Trimble is using it, how people are using it in reality capture today, primarily around feature extraction and what you can do with that. We even get into, are you able to talk to point clouds, and some of the future of working with AI and reality capture data. Alex also shares his perspective on some future technologies like NeRF and Splat. So if you're interested to see where some of the future of reality capture is going, Alex talks to that as well. Thank you for tuning in to this episode of the Point Taken podcast by Trimble.
Let's talk about AI. Is AI being used in the hardware, in the firmware, on the hardware, in our software, in editing? Is that something you're working with a lot with Trimble systems?
Yeah, so I'd say mostly the AI is occurring on the software side. So, I mean, I think it's definitely a possibility in the future that AI is going to find its way more and more into the kind of field aspects and into the hardware aspects. But I mean, for where we're at, and we've been doing AI for a while, we just weren't calling it AI until AI became cool 2 years ago. But like a lot of the things that we're doing with feature extraction, a lot of those are fundamentally what we'd consider AI today with machine learning and things of that nature. And to me, that's one of the most powerful and exciting things with point clouds is you can go scan a site and I mean, let's say you go scan a site, whether we'll say it's some sort of food plant or something of that nature, and you go scan that whole entire site, and you're just trying to do as-built documentation and something of that nature. The beauty of the point cloud and where kind of AI is going is you already have all of the contextual details of that. So today you can go say, oh, like let's say the food plant came back and said, oh, we actually need to identify where all of the sprinkler heads or we'll use fire extinguishers. We need to know where all the fire extinguishers were, and we have this whole point cloud. But what you can do today is you can go, instead of spending, let's say it's a 2 million square foot food plant, which I don't know if that's a very large food plant or a small food plant, but there's a lot of data there in that point cloud. And what you can even now do today is you can go train a custom class of, okay, I'm looking for this object inside that point cloud, and we'll use a ridiculous number. Let's say there's 10,000 fire extinguishers, which I doubt inside of a plant that big, but let's say there's 10,000 of them. Going through and manually finding every single one of those and accounting for human error of, you just scrolled too fast through the point cloud and you missed 3 that really need to be replaced or something. But we can go through and manually find a few of them and then have the AI go and find the rest of them. So sure, it's still a semi-manual process because it's custom and you're saying, I want to find this. So obviously you need to train it on some data. There's probably a future where maybe that's not even necessary, but the example I always like to go to outside is like if you look at a fire hydrant here in Colorado, versus even somewhere else in the US, they might paint them a different color, they might look a little different, and then you go over to Europe and they look even more different, and then in Asia they'll look different, and then in New Zealand, Australia, they'll look different. So like kind of what in your brain you might consider is a standard component that, oh, all fire hydrants are red and have those 2 things on the side. That's not the case even across our country. And like when you think on like a global scale of how AI is going to help you, especially with point clouds, is not everything looks the same everywhere, and being able to have that freedom to kind of have almost your own IP of like, these are the things we know we look for in point clouds because we always scan food plants and they care about X, Y, and Z. I mean, once you train it, if let's say you scan 5 food plants, they're all owned by the same company and they all look relatively the same, you can use that same data that you use to train up finding fire extinguishers in that first one and go through and do that in all of them, assuming that there is some kind of similarity between them. But it's a balance of what everything looks like in the world versus like what your specialization is, and like you can't do everything, but we enable you to be able to do that. And I mean, there's wonderful examples out there, and I know there's some even recent articles that we've had that have kind of shown that.
Right, and it sounds like Trimble's trying to really give that power out to more people to be able to customize that. Whereas, back to your PhD comment, I think there was a time when, yes, we've had a lot of this training a model to analyze a orthophoto and diagnose, is this land, is this water, but some of that was pretty complicated and you kind of really had to dig in for a while. It sounds like Trimble's trying to use AI to just make that simpler, more accessible to people. You still need to know what you're doing. You need to have some good training, some good background in it, but still making it not such a chore to use some of these classification models.
Yeah, and I think this comes back to how we today call 3D scanning reality capture, is that accessibility. So, I mean, let's say for that instance of the food plant, they're going in and they're just trying to do as-built documentation, so they're going to go create even 2D CAD or 3D CAD at the end of the day off of the point cloud data. There's probably 6 or 7 other groups, even inside that food plant, that might be interested in some of that spatial data, but they may have been hired to do that one process to get that one outcome. But where reality capture is kind of going, that I see, is how do we make that data more accessible so you don't need to understand how point clouds work, but this group needs to know where all of X, Y, or Z is and how they can actually start using the point cloud without actually collecting it or really having to know about what the process went in to get that data, but understanding that that's a spatial representation of that plant and all of the other kind of good insights that we can now go after and go towards. Because a lot of the times it's a scanner is used for one purpose, but it could be used for 10, and typically a lot of those groups don't even know that exists or it's possible to get that data from it.
Yeah, I think I saw that, I don't know if it was 10, 15 years ago, with kind of orthophotos or photos from photogrammetry photos from planes or even satellites, where people realized instead of everyone flying the same area, someone would take it and then they could actually sell it on a different platform. Maybe a company was realizing they could just sell that data out to multiple people. Do you see, is that kind of what you're talking about, where maybe you would scan a block in the city of New York and then someone else would be able to access, or were you talking about something different?
So I mean, that could be a possibility. I'm more saying like there's other, like for a food plant, there's probably a lot of people that could benefit from spatial data. But maybe that one group that's just interested in updating their as-builts because they're going to do a renovation funded the laser scanning to occur to redo their as-built or something. But like I'm trying to think of I don't know food plants that well, but like there's a lot of other like machinery and context that you're getting. So like, I mean, the one way that I'll always kind of correlate it to is, I mean, even for like a survey crew or a construction crew is, I mean, you build and then you have to operate that building. Being able to contextualize that point cloud to understand, like if you scanned when there wasn't drywall up, and being able to, I mean, we joke that laser scanners can see through the wall, but in reality, they have historical documentation of what those what behind the wall looked like before it went up. So being able, like, I don't think that's something that is being utilized that well. Of the building was scanned to create an as-built in the beginning, but when you're operating that building, and we need to know where these water pipes go, and maybe it's not so easy in some of the more complex structures, but being able to just even access that and then actually have usable data off of that. And probably one of the most exciting things, especially when you look at like survey or construction companies, is like for a surveyor, for instance, if they go out and they scan a site for where a building is going to go up, and let's say that they scan it. Well, now they have a historical record of what that site looked like, and they have data that's very valuable for the owner. And if something's, let's say they build that building and 3 years later, that same owner is going to go do something else with the property, whether it's an expansion or they want to renovate something or whatever it may be, they have that data that can help them get more work from that same site because they have such rich context of that site. It's not like, to me, it's not like if you just did like a topo or an Alta survey where you have points and control and you're going to tie them into state coordinates. That's good, but that also means that somebody else can just come in and do the work the next time and tie it into the state plane. I don't think that like that's too hard for that to happen, but when you have 3D scans and you have full 3D point cloud of that area, it becomes a lot easier to get repeat work in that thing because you already have the context of what that site looked like.
Okay. Yeah, but I think what you're kind of saying is it's somewhat the value is in the organization. So in the plant example, it's more people within that organization of the
being able to
plant
leverage
owner
the data. Yep.
to leverage that data. So it's still within this confines of a company because you have access to those people and like you can verify stuff. Or potentially in your construction example, it was like the chain of client of a client of a client. You might be able to pass that value down.
Yes.
But it's not like to some random person. It's within the context of, a particular organization or a particular client.
Yeah, exactly.
Okay. That makes sense. And you had kind of mentioned that we were talking about this episode and about how you kind of see that's where it's going. Maybe people in the past were like, I need a scanner, I know I need to scan this. It was very like one-to-one project, but you seem to really think that's where things are going is you're not just getting one scan, you now have this data that you may not even know why you need it at maybe the beginning. You might have that one use case, but now you're using it for many things years later.
I mean, like even like the context of like a forensics crash scene where they go out and they're going to go scan where a car crash happened. I mean, yes, that data is going to be used for whatever may happen with the forensics associated with that, but you're also, you're scanning where a road may have been, what do you call it? Like the guardrail may be like destroyed, and that could be actioned on by the DOT to say that that's something that needs to be fixed. That's not like the best example, but like two totally unrelated groups that probably don't talk to each other that could leverage that same data and work for the same state agency potentially.
Yeah.
There's no pretty way to put it, but like there's a lot more of that can totally happen.
Yeah. Okay, so we're getting into looking to the future, and sometimes Trimble can be a little tricky with what we can and cannot say about things we're working on, but nonetheless, it'd still be interesting to hear, are there technology breakthroughs that you are looking at that you can talk about coming up in the next 5 years? Like what types of technology are you interested in?
Yeah, well, I'd say like one thing that if you go look at reality capture on LinkedIn, one of the things you'll see quite a bit today is all about NeRFs, Splats, and the million other acronyms that they're really calling kind of the semi-photogrammetry, but like
okay.
I'd say that's probably one of the most exciting things because like if you look,
I don't know what NeRF or Splat is. Can you explain?
Okay. So like, there's essentially like a lot of they're doing like it's kind of photo reconstruction of like using images to essentially create a 3D environment.
Okay.
So it could be from like a 360 camera or something of that nature. And like it's going into kind of laser scanners today. Whereas like if you think of like like how a 3D point cloud looks with the RGB on, so like when you have the imagery and you're just seeing the points colorized. So imagine that, except it's much more kind of seamless and it feels like a real immersive experience. It's almost, to me, it's almost like the video game version of the digital twin. But yeah.
You said that term was gone.
I'm half joking.
Yeah.
But like, I'd say that, I mean, yeah, if you look up NeRF or Splat on even LinkedIn today, you'll see probably 100 good posts of people talking about kind of new breakthroughs. And that's a space that's kind of accelerating very quickly of how we actually visualize those photos in kind of a 3D context. And I think, that going forward will probably have a big impact on the visualization aspects and kind of where we can take kind of this technology and where it's going to. I don't know if NeRF Splat or whichever one of them will eventually win and be able to really help get customers answers faster. And I think the exciting part about that is it's not just getting somebody an answer faster, but it can be getting people that are non-technical and they don't need to understand point clouds or 3D models, but being able to contextualize themselves even easier than a colorized point cloud, and they feel like they're actually in that environment.
Okay. Do you think that will get into people wearing glasses, VR, AR more than we are now? Or no?
So I don't know. I like, so with like AR, MR, VR, they're very good for some things and then they're not great for others. Like for instance, like sometimes like it just doesn't contextualize it the way you need it. So like I think some like that's a tough one. I personally like. I think MR and AR will probably have some sort of piece in the future of how we kind of interact with the technology, especially like if you think on like, to me, reality capture is also like going more towards the consumer level instead of just commercial level, where the data might not be represented in the same way, but like if you think of being able to navigate through a mall today, for instance, how are you going to navigate through a mall? You're probably going to go find one of those big billboards that has the map of the mall. Yeah. You are here. But with kind of where AR can go is even data that probably is collected commercially, even from like a 3D scanner or something. We could bundle and contextualize that at the consumer level, where you don't need to go up to something to go navigate through a mall. And obviously, like maps and stuff are getting better, and maybe that's the medium that would help accelerate that. But we can use some of these technologies to even solve consumer problems, even though it was commercially made, with an asterisk, of course. So it depends.
Okay. I mean, I think what's most interesting about that is that you still shop at malls, because now
I don't.
You can actually use the internet to order things online and they just ship it direct, so you actually just thought that was interesting. Okay, a few more questions for you. This one I actually heard from Trimble has been doing, I think, a pretty good job actually of employee training on AI and just making sure that we understand how to use it, maybe as a productivity tool, but then also how we incorporating it in our products safely and with good guidance. And something I heard in one of the presentations from our engineering teams was, will you be able to talk to a point cloud or like interact with a point cloud in one day? And I just never thought of that, but then immediately I was like, oh, how many things would we want to ask our data if there was a way to do that? Like how many fire extinguishers are in this plant, and just asking that. So is that something that you think we'll be able to do one day? And if so, what would you ask a point cloud?
So I mean, I think definitely. So like, I mean, if you think about where we are today, we're essentially, we are talking to point clouds, but we're just not using natural language currently.
Oh, that's a good point, yeah.
So like today you can go talk to a point cloud. It's just not in English. It's in being able to say, I want to find all of these features inside of this point cloud. I mean, you can do that you can do that today. So yeah, I think like that will only become easier. Obviously, there are some manual steps, but yeah, that will totally happen. No promises, but it will happen. We're already doing it.
Yeah, I wonder if this, because once you start to get in that like language, there's like all sorts of things you could ask it, and I wonder if you could ask it like, oh, did I use the right setups to scan? And it like, would it tell you like, oh, actually, you probably should have had a setup over here? I mean, that would be interesting. You think it'll be able to tell us stuff like that, like even assess its own, like how you capture the data and give you advice on best practices?
So I think in reality, there's some ways that it will help us, but I don't think it's not going to be just that easy button of like, where should I put this next scan? I think, they're like, it all comes with context of like, is there, like, if you're trying to say, for instance, scan a building and you already have a model of it, and you can, like, I mean, today you can reference the model inside of the field software. Can it tell you where to go in order to get all of kind of the data you need? Probably. But is it going to be 100% right all of the time, or is it going to tell you to go to that one area that's completely inaccessible right now, and that's the only place it will tell you to do? I think it's like that stuff where people like drove through a lake because GPS told them to. I mean, I think, yes, it's definitely going to help you, but at the end of the day, like, the collection piece has already been streamlined quite a bit, but yeah, it will help you in some areas.
Okay, yeah, I mean, that'll be interesting. You mentioned see-through walls, and I think this was actually a different technology with Wi-Fi, but there was some idea that you could use radio signals to somehow like see through walls. Is that anything you're looking into about the ability of remote sensing to look through walls or materials?
No, not currently.
Not really. Okay.
We're mostly focused on lasers that can't see through walls.
That's for the sci-fi films. Okay,
yeah, I mean, we always joke about Prometheus, throwing the ball up and it just self-navigating the whole entire thing.
Perfect scan. Yeah. So that's not in the cards for the near future, is what you're saying?
Maybe.
Okay. Stay tuned. Maybe.